Hi, hello everyone. So this is the video for topic 4, which deals with functions. Now this is we're going to have two videos dealing with topic 4, and the first one is where we pass parameters to the function by value, and the next one will be using functions and passing parameters by reference. So we'll focus on passing by value on this particular video to give you a basic idea how to use functions in C++. Okay, and as before, I'm going to try to show you the topics, the issues for functions within a single program. In this case, we'll see three different functions. They will all receive parameters, and two of them will return values and the other one will be a void function. Okay, so the very first function I want to create will be a simple function just to add two numbers. Okay, so let's say add two numbers. All right, obviously you can do this just in main, but I'm gonna create a function so every time I want to add two numbers, I can pass the parameters to the function, and then the function will add the numbers for me and return the sum. Okay, so to write a function we need three parts, and again go over the PDF file on Blackboard dealing with function writing in C++ before you watch the video, because in this case I'm going to assume that you spent a little time going over the file. Okay, so the three parts of the function are, and I'm going to write them here where they belong. So function call, this is the location where you call the function. Now the function definition will come after main. Function definition, it'll be here, and above main you will have what we call function prototype. Okay, it's important that you do it this way and you do not put the function definition right here. This is bad practice, and when you become a professional developer, very often you are not going to have access to the main program. You just might be working on a project just writing the function where you do not have access to this. So it's important that you understand how to do it professionally. And so this is it. Three parts of the function. Function call within main for now. Function definition after main. Function prototype above main. Okay, so a function requires a name just like a regular variable name. And in this case, I want to add two numbers. I'm going to call the function add, but you can call it anything. You can call add two numbers A and B. You can call it yellow submarine. Whatever. I'm gonna call add. And I am going to pass two numbers, n1 and n2. Okay, this function is going to return something. Okay, and I'm going to show you the importance to, in this particular case, to receive the number the function is going to return. Oops. Okay. After that, all I need to do is the sum of n1 and n2 is, and I am going to print this. All right. Now, obviously, well, I'm going to save it first. And if I build this thing, obviously this is not going to work because the program does not know, and you can see here at the bottom, does not know N1, does not know N2, and definitely does not know N. Okay, it thinks it's a variable, doesn't know it's a function yet because I need the prototype and the function definition. Okay, so not to worry about. I'm going to clear this for now, and we're going to work on that. All right, so I first need N1 and N2. Okay, I can also show you that this will work. Okay, if I pass, instead of passing variables, I can actually pass the numbers. It's going to work, but for now, I am going to just pass N1 and N2. But obviously, I need to have user input for that. So I'm going to have the user say enter N1. And we already know how to do that. And enter N2. Okay, so now I have N1 and N2. The function will be called. I don't have the function yet. I am going to pass these two parameters into the function add, and inside add, I'm just going to add these two numbers and return the value to sum. Okay, I am going to initialize this to -1 now. Okay, actually maybe 0. Nothing special about 0. How about -99? Okay, and I'm going to tell you why in a minute. So this function has a name add. It receives two parameters, which I'm going to say are integers. You can change it to double if you want. And it's going to return a value, which again is an integer. So now the prototype, okay, I am going to show you what the prototype is in a minute, but it is easier that you do the function definition before you do the prototype. So here is the return type of the function name, and here is the parameter list. Okay, so function name, parameter list. Now in here within this two parentheses, I need to have these variables. They don't have to have the same name, but I also need to have their type. If you just write N1 and N2, this is not going to work. Okay, so I need the actual type. Okay, all I'm doing here is I'm going to create a variable s, and I'm going to say N1 plus N2. And then I'm going to return s, which is supposed to be the sum. Okay, so this is the definition. I am now, this is almost done. It still doesn't work. And notice that the compiler says add is not declaring the scope. So it thinks it's a variable because you don't have a prototype. So to get the prototype, once you've done the function definition, you just copy the first line of the function definition and put it above main with a semicolon. Okay, without the semicolon, it's going to be incorrect. Here is rebuild again, and sure enough, compiler says, yeah, I don't know, there's a problem here. It's missing the semicolon. Now, with the semicolon, I do not have any errors, any warnings, and the program looks good. Okay, so this is all we have to do. Function call, you come up with a name, and you decide the parameters you're passing, that their types, the numbers, and if the function is returning a value. You then create the function definition after main, and for the prototype, this is the prototype, you copy the first line of the function definition, put it above main with the semicolon. Okay, so this is good. I'm going to save it and I'm going to run, compile, run. And I am going to type two numbers. Enter in 1, 7, enter in 2, minus 57. And obviously we know the answer. We're adding these two numbers. Minus 50 should be the answer. The sum of n1 and n2 is minus 50. Okay, good. I'm going to improve this a little bit, and then I am going to show you something else. Okay, so instead of just n1 and n2, maybe I want to see the actual numbers. Right? So I'm going to say this. n1 and n2 is, all right, so now this is going to access the contents of the variable n1, same thing here, and the output's going to look a little bit more presentable. Right, 12 and 10, and sure enough, the sum of 12 and 10 is 22. Okay, this looks good. Now, what if I did this? This compiles. I don't have any errors here. No errors, no warnings. The only problem is, what do you think it's going to be printed right there? I'm going to call the function add with n1 and n2. It's going to add these two numbers into S, and it's going to return S. Let's see what the answer will be. I'm going to put 6 and 4. And here's my answer. Minus 99. Well, it should have been 10. But why is it minus 99? Well, when you did this, the compiler calls the function returns S, but you don't store it anywhere. This should have been put in sum. And because you didn't, and when you went in here to print sum, the value that got printed was the minus 99. So for the functions that return a value, you must have an equal sign assigned to it, otherwise you lose the value. Another way you could have done it is call the function from right here and print it directly. But this is a better way. Okay, so this is function 1. Just simple print two values. Okay, perfect. All right, so you have an idea. How about, let's create a function that is going to, I'm blocking this because I don't need that part anymore. I want to write a function that is going to print, maybe return the factorial of a number. Okay, so I am going to say factorial of n. So you remember n factorial, right? N times n minus 1 times n minus 2 times all the way to 1. Well, actually 0. But 0 factorial is 1. So we're going to stop right here. Okay? So I'm going to call this function factorial. But as you know, you can call it anything you want. The function now is receiving only one parameter n. And again, I need to store it somewhere. Okay, and because factorials can get pretty big, I am going to have a long variable instead of an integer. Okay, and I am going to assign this function to that. At the end, all I need to do is print maybe I want to do something more sophisticated. Well, this is the factorial of and n is, and here is, I'm going to write it here, and then I'm going to do a variant so that you can see what else you can do. Okay, now this doesn't exist yet, and neither does n. So I am going to create an integer, and I am going to collect user input. So enter n. So the user is going to enter n. I'm going to send it to the factorial function, which will be defined down here. So remember, right? Function call, and here's the function definition. Now this function, it receives a parameter n and returns a long integer. So this long means long integer. So you can write it long int, or you can just write long. Normally we just write long. Long factorial, and here's the parameter. And I need the code that is going to return the product n times n minus 1 times n minus 2 all the way down to 1. So normally you have to understand that n must be 1 or more. All right, actually 0 or more. All right, no negative numbers allowed. So what do we do here? Okay, so because I need a repetition, I will use a loop for that. So I'm going to use a for loop, int I equals 1, I less than or equal to n, I plus plus, and I need something for the product. It's going to be a long, I'm going to say product, and this is important. You need to set this value to 1, not 0, because it's going to be multiplied. All right, so product, and here's the operator for multiplication, but you could also do it this way if you want. Product times I. And at the end, I am going to return product. All right, so let's see if this works. So let's pretend the person passes in a value n equals 3. So we know that the product should be 3 times 2 times 1, which is equal to 6. All right, so let's see if this works. Product begins with 1, and I'm going to go from 1 to less than or equal to n, which is 3. So the first time it comes here, I do 1 times 1, and then I'm going to increase this. This is still less than or equal to 3. Next time I is 2, so 1 times 2 is 2, and this is still okay. I increase it to 3. 3 is less than or equal to n because n is 3, so I go in once more and I multiply the product, which is currently 2 times 3, which is 6. I increase I, so now I is 4, and this test fails. So I skip this line 51 and I return the product 6. So it seems like this thing works. Okay, I am going to save this, and I'm going to copy this line, and I am putting it as the prototype. And remember, for the prototype, just copy the first line of the definition and put a semicolon. All right, so save. Let's build to make sure I don't have any mistakes. Okay, no errors, no warnings. And now the code is going to do this and return the factor. Okay, so let's see. So I'm going to run and I'm going to type in the number 3 to check. Let's say 3, no, not 33, 3, and the factorial of 3, 6. Okay, that looks good. So maybe one more number, about 5, 125 times 4 times 3 times 2 times 1. Yeah, that's correct. And you can test a few more values, but that's the idea. Okay, another way you could have done this problem was, instead of typing the variable sum here or fact here, you could have called this guy immediately from here. So you can call the function in here. So factorial, and I can pass the variable. So now I am close this function call, and I'm going to call it from within the cout. That is allowed. Let's build to see if there's no error, and I'm going to get the same answer. Okay, how about 3? Well, how about 4? So this should be 24, the answer. And here it is. The factorial of 4 is 24. So this works. In some instances, you have to be very careful what the function return, because the object cout is very specific what it recognizes. But in this case, it's okay, and I can do it that way. So if you want to do it this way, which is more formal, you can, or you can do it this way as well. Okay, good. So this is perfect. So let's do our last function. A function that is going to print, it's going to receive 2 parameters, and I want to print values from A to B. Okay, so the user is going to send 2 parameters to the function just like before, A and B, 2 integers, and I am going to print from here to here to the screen, maybe separated by a space. And we have to be sure that this is A is less than B. So A, maybe less than or equal to B. If not, then print a message. Okay, so let's see. Now this function just prints. It doesn't return anything, so it's a void function. Okay. So instead of how about, oh, I guess I can create 2 more variables, int A and B, and I can borrow this from above, and I can put it right here. So, whoops, here, enter A, enter B, A, B. All right, and I am going to call I'm going to call it print AB, and I'm going to pass the 2 parameters. All right, now this function does not return anything. It just prints the values from here to here. All right, so this is important. I'm using these lines here just to clarify and subdivide so that the person reading these functions doesn't have any difficulty knowing where it begins and where it ends. Okay, so if a function does not return anything, it's of type void. Function name, print AB, right? That's what we wanted to call it, print AB. And here are the 2 integer parameters again. Seems like we're only using integers, but you know, this could be double. You can change this to a double. Nothing special about integers. Okay, so int B. In fact, I guess we can do this immediately after so that you can see that nothing special about integers here. Okay, so to print the values from A to B, I'm going to need a loop. But before that, I need an if statement. So if A is greater than B, right, because we're assuming that A must be less than or equal to B. If A is bigger than B, I am going to put out a message that says A is not, maybe I can say that A greater than B. No output. And I get out. Otherwise, I'm okay to go. And so here's my for loop or while loop, whichever you prefer. So int I, and I'm going to go from A, that's my starting point, I less than or equal to B, I plus plus. All I'm going to do is print out the values with the space in between. That is all that I'm going to do. And maybe I am going to, instead of putting this here, I am going to put this after everything else. Notice that this cout is not in this for loop. It's outside. Okay, when I don't have the braces on a block, on an if or for or while loop, that block only accounts for a single statement. If this is confusing for you, you can always do this. So this is probably better because it's clear. So now you can really see the cout this cout does not belong to this for loop. It's after everything else. Okay. Now this is my function definition. I need the prototype. This is not going to compile yet. Let's see, because I don't have a prototype yet. So the compiler says, yeah, it's not declared. The reason for that is you have to have the prototype. Now, as I said before, do not put the function definition here. It's bad practice, and it's very likely that when you become a professional, you will not be able to do that. Okay, no problems. So I am going to test the program very first with A being bigger. So how about 12 and 4? So I cannot print from 12 to 4 in increasing order, so this is going to give me the message. A greater than B, no output. Okay, perfect. But if the numbers are equal, I don't have a problem. Sure enough, it just prints 12. And if the numbers are, if A is less, it's okay. So how about -3 to 6? So it should print from -3 all the way to 6. And it does, so we're good. So this program is perfectly fine. The function is fine. And it's a void function because it doesn't return anything. All it does is print the values. So before I finish the video, I just want to say, let's change this, the add function, to a double. Because I want you to see nothing special about integers. Okay, obviously if the two numbers being added are double, the return value must also be a double. Okay, I'm gonna close this for now so that we don't use it anymore. I'm gonna focus on the integer first. And here, all of these three variables have to be double. All right, and now I've changed the function call it was not changed. The function definition was changed, and notice the prototype, it's still integer. So if I try to compile now, it's going to issue either a warning or an error. Okay, so that's a problem. So I have to change this to a double, 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 and double. All right, let me save, and let's see if there's an issue now. No warnings, no errors. I'm going to run the code. I can still run with integer values, 4 and 6, 4 and 6, and the answer is 10, no problem. But now the advantage is I can use real values, 3.44, 6.12. So I should be 956. Okay, so here is N1, here's N2, and look what happens here with my sum. Why is it that sum is 9? Okay, why is it that the sum is 9? Let's see if we can figure it out. There may be a problem here. So there's nothing wrong here with the sum. Sum is double. I am passing two doubles. I told the compiler I am passing doubles and returning a double. Can you see what the problem is here? This is fine. Here is the problem. You add the two numbers, but you add them in an integer, so the decimal part is lost. So I have to change this also to a double. Okay. Build everything. Run. And now, what did I put? 6.12, 3.33, 9.45 is your answer. Okay, perfect. So you have now seen how to pass functions by value. In all these cases, the functions, these three functions with their parameters were passed by value, which means a copy of the actual parameter or parameters were passed to the function.